We're looking at two-dimensional motion with a constant velocity and your equations relating them. So we are basically writing up the equation that will help us solve problems when it comes to two-dimensional motion with constant velocity. So we'll start off with the basic idea. A particle moving with a uniform velocity has zero acceleration. So this is constant acceleration. So acceleration, constant velocity. So acceleration is zero over here. It travels in a straight line at a constant speed, right? No acceleration means no change in direction or no change in speed. So only thing that you guys have to be bothered over here is your position vector. So we find the object's location using its initial position, that is your RO, right? This is your position vector, and the velocity over time. So we are looking at, let me actually read it off. Okay, let me explain this way. Position vector equation actually. So we can start off by looking at what is position vector. So you have, let me do this. So you have a particle over here, right? And say it moved over here. So the particle started off with this space and went on to this space. So this is your initial position and that's your final position. So the position vector is r naught and this is r. Remember, this particle is moving with a constant speed. So basically the particle is moving in this direction with a constant speed. So we'll figuring out the expression for this r. Okay. So the particle is moving this way. So this r is equal to r naught plus the velocity times t. As simple as that. Okay, so r is equal to r naught, velocity times t. There's no vector. Again, I'm not able to type in the vector notation. That will just consume my time. So I'm going to write it over here. So you guys always have to write it in the right way. So let's have a look at one question. So we have a particle moving in this manner. So the particle starts off from 1, 2, somewhere over here. And it has a velocity of this. So you can see it's not varying, it's fixed. The acceleration is 0 over here. Find the new position after 2 seconds. So it's quite simple. So r naught as a vector representation is I cap plus j cap. Is this correct? No, 2 I cap plus j cap. Now is it correct? Nope, now also it's not correct. It is I cap plus 2 j cap. Is this correct? Yes, this is correct. And the velocity is given by 2 I cap plus 3 j cap. Right, now we have to figure out the, I'll write it here itself, the new position when time is equal to 2 seconds. So it's quite simple. R is given by R naught plus V times of t. So this is I cap plus 2 j cap plus 2 I cap plus 3 j cap. If you think about it, it's very commonsensical, into 2. I'll do the math directly. 1 plus 4, that is 5 I cap. 2 plus 6, that is 8 j cap. And that would be it, right? So let me 5 and 8. Perfect. Actually, let me take some time and let's actually discuss this. As in, Let me put it across in this manner. Let me draw the path of the particle. So we have the particle at 1, 2 if I'm right. Okay. So I'm not putting the tick values. So this is 1, 2. Now the particle is taking 2 unit right every 1 second. So every 1 second the particle is moving 2 units right. So 1, this is first second and second second. So the particle is over here at t is equal to 2. This along the x-axis. Now along the y-axis it's moving 3 units. So it was here, it has moved 1, 2, 3 and 1, 2, 3. So this is when it is at 2 second. The line will intersect, the points will intersect over here. Okay guys, and this is how much? Wait, there's something that I missed. Oh sorry, this is 1, 2. I took it as 2, 1, my bad. Yeah, 1, 2 is over here. And the particle moves 2 units every 1 second. So this is first second when t is equal to 1 and 2 more second when t is equal to 2. And here 3 units up. So this is t is equal to 1 and t is equal to 2. The place where this 2 intersects is over here. And this will represent 1, 2, 3, 4, 5. So this is 5, comma. And this is 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? And what answer did we get? 5i cap plus 8j cap. So you can clearly see that we can compartmentalize the discussion, we can break down the discussion, and we can always understand all of this with simple one-dimensional motion. Just that we are just using some I and j, a simple set of letters. This is t is equal to 0 and this is t is equal to 0. Yeah, we're just using simple set of letters and we are able to combine and we able to get the answer. Okay, so basically the particle is moving this way. Particle is moving this way, or not that. From here it is going forward. See, at 1 second, if you map it, can you see that? It's exactly on the, right, 1 and 1. Can you see that? It's exactly on this line. See everything, how it adds up, right? So that's how simple it is, guys. Literally, if you understand this, if you felt that it was, I mean, it's that obvious. It is that obvious. I can't, I am not making it complicated at all. As in, there's nothing to complicate it over here. It is just that simple. Okay, so that would be your position vector equation. Right? Oh yeah, there is some more, sorry. Measuring displacement. Displacement is nothing but, let me do this over here. So what is displacement? Displacement is nothing but change in position vector. So displacement is nothing but change in position vector. So RF minus RI. So how is RF given? R naught plus VT. All these are vectors, by the way. Right? VF, or in this case it's constant. So VT. Then this is TF, by the way. Time. Oh yeah, time will change over here. Minus R naught plus VTI. So what will happen? R naught will get cancelled and we have velocity is common. TF minus TI. So this is nothing but your change in time. So delta T times of V. Remember this is constant. And so we have this. So your displacement is given by a simple delta t times of v. Okay, so there's an example. So it's just a matter of multiplying the velocity with time and you have your displacement. So here you can see the displacement in this example itself. Displacement is to be considered from here. So it is this point and this point. So displacement is 4 units and 6 units, right? So yeah, see, you got it. This is 4 units along the x-axis and 6 unit along the y-axis. So for this particular example, displacement is 4 unit along the x-axis and 6 unit along the y-axis. And that will be your answer. Anything else? Velocity vector. Velocity is constant over here. So there's no per se any further discussion. We can go back. So we are looking at equations of motion when it comes to two-dimensional motion with constant velocity. Means there's no acceleration. And our position vector will look like something like this. And this is your example. And this is a related graph of that example. And this is the topic of displacement. After this, you have the topic of displacement. This is the write-up. And for me, I've taken this as the example itself. And finally, the velocity vector is just the expression 2i cap plus 3j cap. It is not accelerating, so nothing to discuss over here.